session. So I'm going to keep track of people, and Laura is going to keep track of answering. Remember, once again, a hand is a new question, and a finger is a follow-up. And please keep your hand up until I give you a nod so that I have you written down in my little book. So, David?
What's wrong with the following way of thinking about it? I'm not sure there's anything wrong with it real quick. So I think something like this. Leaving aside non-gravitational phenomena for a minute, I think about standard model. The universe is the accessible universe to its horizon. I'm not sure how to model that. It's at least kind of reasonably plausible to suppose that we can think about the kind of occupying station by that region one way or another. We know from the normalization theory that what we do on the arbitrarily small scale of freedom doesn't make any difference when it's structural about theory are accessible to freedom. So in particular, insofar as we're interested in phenomena at the including unobservable phenomena at any given length scale, we can account for some particular short length scale. The theory we have then is not pure infinity in the finite quantum theory. Now, of course, that doesn't mean that we don't want to employ various kind of idealizations involving infinity to do things like model quantum mechanics, and we learn to be sensitive and pluralist and prescriptive about the way we handle idealization and approximation. It also doesn't mean that we don't want to consider using resources of pure infinity to think about ways of going beyond exam physics, and again, it makes a lot of sense to be pluralist about that prescriptive, scheme accounts all. But insofar as you want to interpret the project of metaphysics as something like that, what does the world look like on our current physics, then it's not clear to me where the Q and infinity problem will hit that project.
Yeah, okay. So Q infinity is playing a rhetorical role here of kind of dramatizing something I think is more widespread in physics than can register on people who are paying attention to theory T rather than, and I don't know enough about how the standard model actually gets away with what it gets away with to know whether what Q of infinity I think dramatizes is the extent to which, in order to get pieces of physics to succeed on terms natural to them, we often have to answer significant content elaborated questions. And Q infinity dramatizes sometimes different answers are needed, sort of plural sensitivity, situational dependence of how you're using the theories, what's required to get out of the theories that we need to get out of it. My hope would be, although I would also be delighted if this were wrong, that the same kind of morals could apply to the theory we were talking about, the standard model considered as low energy approximation to whatever's really going on, and considered as applied only to the visible universe. What should be a project for me is looking at other theories besides the ones I've looked at and seeing if in fact this is a kind of generic.
Yes, and at the moment it's kind of not clear to me to what extent this could turn out to be a phenomenon, to what extent it's coming up with factors which are particular to because if the latter, then it starts to rest very much on matters of how one thinks of that, and exam divides out between objectivity and applications.
Yeah. So the worry is how much the pluralism, context-sensitive artifact of infinity, Q and infinity. I tried to use examples of virtue fracture where the fracture of the virtue has something to do with features of the theory other than choices about limits. The infinity in Q and infinity confronts you with a choice about limits. There's different sensible choices to make. I think some choices are appropriate to some circumstances, other choices are appropriate to other circumstances. But both the examples I gave, the different interpretations weren't indexed to different choices about limits. They were indexed to agreeing on what the observable algebras are, agreeing on what CCRs are, different choices about the set of possible states. And I also want to say, the thing about the scientific image being still under construction makes it important that lots of different ways of going after science are alive at any given time, including ways informed by metaphysical intuition very different from my own, including ways informed by metaphysical intuition that are philosophically respectable. So don't want to talk anybody out of a different way of thinking of the world.
Jill?
So I have, this is a really naive question stemming from not knowing about QFT, so I'm just going to ask you. To say whether theories are equivalent, we need some standard or some way of saying that they're equivalent. And you were saying, I guess, different ways of quantizing classical field theories give rise to continuum many physically inequivalent theories in the sense that they're unitarily inequivalent. So I was just wondering, has anyone ever said, or is there any way of saying that those unitarily inequivalent theories, there's some other underlying structure they all have in common, in virtue of which we say that they are in fact physically equivalent, or is that just a crazy idea?
That's an outstanding idea. It's the right idea to have for a history of philosophy.
Yeah.
Just abstract up a level.
Yeah, sure, or something.
Or
I don't even know if it's abstracting up. It's I don't know, finding some structure they have in common.
Right. So the answer is, yeah, there is a structure they have in common. In a way, it's not so surprising there's a structure they have in common, because each of these theories starts with the same set of commutation relations.
Yeah, right.
Remember I said that was an algebraic structure?
Right.
And remember I said choices about limits kind of fraught significant question what you're going to count as a limit. The way we're brought up doing quantum mechanics, our choice of a definition of a limit of a sequence of operators, you need to make a choice because the sequence of operators is a sequence of numbers, and you need to find a way to map sequence onto numbers so that you can borrow from what it is for a sequence of numbers to converge and account for it. There's lots of ways to do that. The way we do it in ordinary quantum mechanics, what we wind up with is the set of bounded operators on Hilbert space. It's pretty permissive. A lot of sequences converge. There's another way of doing it, perfectly good definition of limit, that's kind of Stirner criterion of convergence. Fewer sequences converge. And when you add limit points according to the Stirner criterion of convergence, according to which fewer sequences converge, you wind up with a smaller algebra. And in that case, the kind of algebra you wind up with is called C-star algebra. The kind of algebra we're used to working with, where you use the more permissive criterion of convergence called von Neumann algebra. It's the case that if we start out with the same canonical relations, we each go off and find our representations, each builds a C-star algebra. Our C-star algebras are isomorphic. They're the exact same C-star algebra. Okay, so the interpretive loop. And so this is like a layer, so this is a kind of content elaborating question that I think is a really interesting content elaborating question, like how big do we want our observable sets to be, what criteria of conversion should we use, and why. But an interpretive maneuvers say, we've been misled all along in thinking the Hilbert space is so important. The Hilbert space is a bunch of accidental accretion to the real physical core. The real physical core is C-star algebra. So let's start with C-star algebra. When you apply the same conception of states, criterion drops out of it. It no longer makes sense. It's no longer well posed. Countable activity criterion is no longer well posed. You wind up with a bigger space of states. And then there's a kind of interpretive drama, given the thing you're doing with a theory like this. And given this kind of pair of kind of natural choices, I'm going to work with a concrete Hilbert space representation, the physically reasonable one. I'm going to work with a C-star algebra. There's interpretive questions about which choice does the work you need the physics to do. And there's a line that physics forces you into situations where the C-star algebra seems like the way to go. For instance, there's kinds of dynamics that can only be realized with dynamics in C-star algebra, but there's other situations where bigger concrete Hilbert space, the bigger algebra is the way to go. That's another way of making my point. Because you've got to choose your sense of limit, and on your choice of a sense of limit hinges the question of which observables are physical. In different applications, different choices of limits eventuate in a sets of observables that are appropriate.
And the difference between the C-star algebra and this, is it the bigger algebra? I forget which is bigger. The von Neumann algebra. It would be going too abstract or something to say that they have something in common, such that these are all physically equivalent.
So living in the heart of every von Neumann algebra is going to be a C-star algebra. So the von Neumann algebra is going to be the C-star algebra, some extra stuff. But to say there's something that I can identify they have in common, but part of it you throw away when you're doing that are the observables additional to those real life. And these observables can do serious physical work. Since the quantum field theory is a total number operator, is one of those things you don't get in the C-star algebra, but you get in the von Neumann algebra.
Okay.
In quantum statistical mechanics, suppose you were concerned to make sense of ferromagnetism, this iron bar, I'm not in an infinite system. Sometimes it sucks the glasses off my face, sometimes it drives them away. We can fall into different magnetic states. The observable pertaining to the iron bar is a total magnetization. That's not in the C-star algebra. So if you want to talk about these phase transitions, you're going to want to even just set your explanatory goal, but sometimes there's no magnetization, sometimes it's like that, sometimes it's like that. The physical magnitude that describes the phenomena you're trying to explain isn't one you get with the C-star algebra, so that's the kind of case where you want to expand.
Jonathan?
So I have just a very general methodological question. I took you, and I hope I was understanding your answer, so just cut me off if it's misunderstanding. But I took you to be suggesting that it was sort of neutral to use the kind of Locavore strategy because the realist was reliant on the hopeful result that the Locavore strategy would produce one and the same best interpretation for every context. And I thought that was a bit too strong of a demand on the realist. So I was imagining, just to kind of illustrate a kind of case where I thought the realist would be really happy if it didn't still fit that recipe. Imagine that in all but one interpretive context, interpretive schema I1 is the runaway winner. But there's just this one interpretive context in which I1 is just a close second place to I2. That seemed like, if you're a realist, you got to be thrilled with that. So, and that seemed that in general, like, generalizing beyond that a little bit, it seemed like the realist should be happy enough, in approaching these issues with like Q infinity, which I don't know very much about to comment on specifically, if she could somehow advert to other explanatory contexts that we haven't considered here that might make her want some kind of general piece of interpretive machinery that could help her. So it seems like the realist has some more, in virtue of her more global ambitions, has some more methodological.
Right. Now, I agree totally. I talk really fast and buttered, but I said the realist hope is for enough. And the way the realist can deploy the resource you've just attributed her is, was it a success that's contingent? So by a dual strategy of saying enough is enough and discarding some cases where the favored interpretation doesn't work as cases where the explanation demanded isn't, the demand for explanation isn't well posed. I think the realist can constitute a position she can take the explanatory success of the theory she's making sense of to support. I think that's right. But there's a further question when you look at particular theories. Can even this augmented realist strategy deliver the goods? And my suspicion, which I don't take myself that established, I'm just trying to suggest it, just trying to open the field, the possibilities is maybe not.
Z?
So this is sort of in line with Jonathan's question. You might think that that some of these reasons to sort of relax the constraint on the realist might also make you think that the sort of arguments in play should be a little bit different. Maybe in particular we shouldn't be thinking that interpretations are supposed to be doing the job of explaining theories understood as these sort of like uninterpreted things, but rather just saying, oh, in fact, we were just being sloppy. It turns out that we were trying to get some hay out of whatever we call success when given to this really broad thing. Really, we should be looking at the success of the theoretical virtues had by certain interpretations. And maybe there will be some argument that works this way, and there's certainly now much more work for the realist. But at the very least, you might think that any of these sort of these issues, whatever could be sort of interestingly attributed to the uninterpreted thing, but not to any of the, or not to any interpretations in the right way, might just be the sort of thing that the realist would be maybe happy to get rid of. The same way that, like, a realist might be okay to give out, they're like, what, fertility, yeah, it turns out we just have no claim on that, but that's okay. You might actually think that if the realist is really interested in truth conduciveness, it might not be fertility seems to be the very thing that makes a theory good when it's not true, right? A true theory that led you to believe some other interesting theory, unless that other interesting theory was also true, doesn't seem like a great feature.
Right, yeah. So let me start with fertility. In fact, I'm going to say something more about how I'm understanding interpretation. That's not going to be like a direct response to what you said. But I want to get off my chest. Part of why I'm focusing on fertility is part of it is that I think it's an important virtue of theories we have now, and we're talking about what lessons, constraints, information we can get from the theories we have now for how we understand the world. But I also think it's a sort of these snazzy modern day realism is kind of important virtue. Like something Richard Doyle makes a big deal about is the mature sciences, the practitioners of the mature sciences are very good at judging what are fruitful avenues of research. How do we explain that? It must be that the ways of organizing and thinking about the world afforded them by the theories we have now are onto something. Not that they're flat out true, but there's something true about them. So insofar as scientists are good at crafting a future for science, according to Boyd, that's one of the reasons we should think our present mature sciences are on the right track. As a kind of structural realist, there's many kinds of structural realists, but there's a kind of structural realist where it's significant that over the history of physics there's a kind of structure that's preserved, and that's what we have reason to endorse when we're striking our structural realist attitude towards a theory. Doesn't seem like too much of a stretch to say when the attitude the structural realist recommends toward our present theory of believing in structural part that will be preserved is an attitude according to which our present theory has the virtue of fertility for its future theory, because it has in it the structure, that's the seed that will be reflected in the future theory, or the genetic code for the future theory. So I agree. I think your opening characterization of a kind of move available to the realist is absolutely right. And I don't take myself to have argued conclusively that realism is bankrupt. There's this sort of working assumption it makes. And depending on how widely you understand theoretical virtue and how closely you look at theories, that assumption can be more plausible. But nevertheless, I'm not that uncomfortable. I think it's cheating too much if I go that out and to take fertility to be a significant virtue of the theories we have. About interpretation, the picture I'm working with is physical theories. They come kind of already interpreted partially. They typically have some or a number of mathematical apparatuses, the framework, and some kind of working assumptions that nobody questions about how to bring these mathematical apparatuses to bear in the business of physics. The position operator represents something we measure by localizing things. The momentum operator represents something we measure with springs. The stress energy tensor describes matter in space-time. The curvature tensor says curvature in space-time. It's like this common core, something everybody accepts in order to do physics in a way framed by the theory. And that common core, I think anything you add on the mathematical structure is interpretation in the sense I'm working with. But there's more and less contentious kinds of interpretation. The most contentious kinds of interpretation are the kinds of foundational questions that are often the province of philosophers of physics. But I think questions that sort, or I think extensions beyond the common, uncontroversial, received core that launched the history of this theory as a physical theory, are often questions physicists need to answer to do physics. And I think that's interesting. Part of what I'm trying to say is these are still interpretive questions, and sometimes they need to answer. Physicists need to answer the questions in different ways to do what they need to do.
I'm a little embarrassed about this, but I forgot your name.
The question is sort of past at this point anyway, so it's fine.
Great. Well,
I'm Porter.
I'm picturing Sorry, Porter. All right, Heather.
know, I'm really sympathetic to the no miracles idea, that the success of science is we have to be getting something right. And I've always thought of the realist interpretation as that link. You know, that's what tells us, you know, that the equations are why are they successful? Well, because the equations represent something going on in the world. And so I just would like to hear more about how different interpretations can be so successful if they kind of contradict each other. If one says they're particles, the other says no, they're waves, and you say, they're both equally good. And then what do you do as a metaphysician? Because you want to know what's the world like.
Yeah, that's what I'm good at. It doesn't help you as a metaphysician.
Okay.
Okay. So I obviously Ben Brown is a kind of hero of mine, and there's this thing he has on, and his what interpretation is. You're probably familiar with it. What it is to understand a theory, according to him, is to kind of get a grip on its manifold of interpretations, interpretive questions. Don't call for, don't demand on the basis of unique answers. I sort of agree with that. And this is something I've gotten from looking at theories and the terms of their success. That it's actually a strength of a theory that it admits lots, that it confounds the metaphysician, that it admits lots of interpretations.
And do you see it as like an epistemic point then? I mean, are we giving up on like there is no way the world is? Or is it just like, yeah, no, there is a way, and there would be a good interpretation maybe if we had the final theory or we were smart enough, but with like an epistemic way.
Yeah, so I totally think there's a way the world is. And so there's a theory. I think there's a theory. I think there's lots of theories that describe the way the world is. In the sense, the different theories that describe the way the world is situate the world as it is in different spaces of possibility. I'm ecstatic for other people to think that, metaphysicians and philosophers too, because of the scientific images under construction, and the more ways we go at it, the better we're going to do. I myself, in my heart of hearts, am leery of calling any of these possible theories that are adequate to the way the world really is final physics, because in order to get there, you've got to get rid of this ambiguity I'm talking about in the theories we have, and my suspicion is this ambiguity is part of how the theories we have are purchasing the successes they're purchasing. My guess is this is going to be a feature of science as long as they're science, but it's a guess.
Okay, David?
Just thinking more about notion interpretation. I mean, I wonder if we're actually, in some way, talking about two slightly different kinds of thing rather than two variants of the same thing. I mean, I can kind of understand the second sense of interpretations playing out, particularly in the Q and infinity case, but I struggle to get a non-Procrustean analysis out onto the various how-do-you-solve-measurement problem situations. I mean, in many cases, those involve additional pieces of formalism. In some cases, they actually involve additional predictions. Yeah. I mean, I can, if we kind of dramatize where it is, I can well imagine being persuaded by you that, yes, indeed, we need to be pluralist about the way we think about our various quantum mechanics and the various ways we interpret them and apply them. Of course, they're all Ruetschian, because that's the only way to make sense of the quantum mechanics. But we should be a pluralist about these various thoughts and Ruetschian quantum mechanics.
I don't mean to. I'm happy to count approaches to quantum mechanics that add dynamic law, take the adequacy of the quantum formalism that we're taught in our physics classes to derive from the fact that there's a swarm of Boolean particles obeying guidance equations in which very much we know in the world of matter. I'm happy to count those as interpretations. By saying when we think of a theory as a sort of received core of the theory, I think it's allowed interpretive move to revise the core, augment the core.
To the point of testability.
To the point of testability. And I don't want to get too exercised on questions. The GRW theory versus orthodox quantum theory are different interpretations of the same theory.
I just, that when I start to use interpretation, I mean, it's a sociological claim. And I find that the strategy is enormously unlikely. If it turns out that we do some of these rather delicate space satellite laser table experiments and we indicate something like the Penrose style gravity This will be widely recognized in physics as a kind of revolutionary result, breakdown of quantum mechanics, precisely replacing quantum mechanics with a new theory for which quantum mechanics is simulated just as blah, 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 blah. I mean, in that kind of interpretation, it feels that it's been stretched rather broad, more broadly than the...
I don't mind the stretching as long as how we're adjudicating the different contenders makes sense. I was going to say something else, but I lost it. I'm not sure. I don't want there to be I don't think there is a sharp distinction between elaborating a theory in such a way, it's an elaboration, and modifying it in such a way, it's a new theory. I think as long as they're clear about your bookkeeping principles. And maybe a way to accommodate the position I just said I wasn't interested in defending, that the Penrose thing is an interpretation, is to slightly modify the account of what an interpretation is. An interpretation tells you how the rule could possibly be such that the theory succeeds as well as it does. And there's ways of doing that where you take the condition of success of the theory to be its truth, but there's ways of doing it where you take the condition of the success of the theory to be its capacity to approximate something else that's going on.
Okay, then I worry a little bit about kind of early to dialectic in that case. So you're coming in as going to be people who would like to be realists on general ground with quantum mechanics and quail, and fair enough. But those who look at quantum mechanics and quail and who know quantum mechanics, sometimes the reason they're quailing is they think, well, actually, hang on, that isn't the theory that works. What I need is something else.
Right.
And they don't know what something else is yet.
Right.
And other people look at it and say, oh, well, actually, I'll rethink even the kind of lower level realism, and I'll fall back to something much more radical, that's a lot of physics unit matters. And some people look at it and say, actually, okay, well, just going to you realise that realism is finding after all. And most of the self-defined realists in mainstream physics comes on differentials on those kind of grounds, but then it doesn't feel as if many of those are categorised as people coming at the theory and thinking, okay, well, I've got lots of... the reason I go quail is because I've got too many ways of being realist, rather than I've got no ways of being realist at all, which is characterised by more of the problem. You've got Fuchs and Harris will say, well, we like to be realists about, we've heard they have about realists about science, probably that tells us we can't be realists at all, we need to be a quite radical single operationalist. L comes along, Penrose comes along and says, well, I want to be a realist. This theory is insuitable for me to be a realist, so the theory needs to be messed with. Everyone comes along and says, well, we're realist. Well, this is Deutsch, they come along and want to be realist. Oh, I can, that's fine, let's get on with it.
Yeah. I think the move of holding out, I think the realist is allowed to hold out hope that at some point we're going to understand why quantum mechanics succeeds as well as it does. I don't care whether you call that understanding an interpretation or not. I think you're right that at some point it just becomes a distinct physical theory. Everybody agrees to that. But I think it's fine for the realist to hold out hope that at some point we're going to understand why quantum mechanics succeeds as well as it does in terms of a theory that fulfills the Cyclopsian hope. There's a theory that enables realism and naturalism. But part of the dialectic is I'm thinking about the theories we have now. I'm thinking about what to make of the world and what are the theories we have now.
No.
This is actually kind of similar to Dave's question. So I find myself in a position of wanting to agree with most of what you said, but still wanting to be a realist of some stripe. And I guess when I originally read your book, I was thinking that you were still a realist of some stripe, and now I'm starting to doubt that. So would you describe yourself as anti-realist?
Yeah, but not for any reasons not having to do with how I think people are.
Okay, that's fair. Okay, so I guess.
I just don't know what I believe if I were a realist. I describe myself as confused.
So I guess here's the kind of realism that I was thinking might be compatible with what you're saying, and this might end up being sort of a poor
I think there's realism compatible with things.
Oh, okay. So
Tell me.
let me describe this one, and this might be sort of a poor man's structural realism. I'm not sure.
Yeah.
The thought is something like I'm going to be sort of a minimalist particularist realist. So minimalist in the following sense. to be a realist is just to believe that there are certain facts that are confirmed by the data that outstrip sort of the observational part of my theoretical structure. Right? So, as long as I believe certain theoretical claims and believe the world's actually that way. And
Do you have to know what the theoretical claims you're believing are?
That's sort of weird. Pull that up, though. Okay. And then it's going to be particularist in the sense that the degree to which any given theory warrants a certain amount of belief that goes beyond the data will depend crucially on the way the world is, the kind of theory, the kind of possible interpretations that are left open, that kind of thing. So, for example, it may be the case of, when I'm comparing interpretations of ordinary quantum mechanics, there's not very much theoretical content at all that all the various interpretations share that warrant me to go beyond the empirical predictions. But say in the case of inequivalent representations of a C-star algebra in quantum field theory, there's actually quite a bit of theoretical content they all have in common. In fact, all the stuff that I can appeal to is just a C-star algebra. So the reason why I think this is actually tenable and not, so the worry is that if you don't have the picture of the way things are really at the fundamental, so I want to say that actually you do want to say, well, I need additional things that these various interpretations disagree on to sort of make sense of the world completely universally or at a fundamental level. But I'm sort of more skeptical about those things that don't appear in kind of the common core. But I don't just want to mod them out. And then the worry would be that my uncertainty about that will sort of ramify up and make the stuff in the common core, it's not clear exactly what I believe when I believe what's going on up there.
I feel like the more you retract the core, the fewer successes you can gesture to as the objective base for belief in the theory.
So this is the particularist thing. It seems like there would be some cases where the core is very, very small and doesn't really admit very much in terms of explanatory power, and other cases where it's fairly big.
Yeah. And like I can say, that's definitely a live possibility. I don't mean to rule it out. Just looking at the theories we have, I have worries about whether the core is successful enough. I mean, this seems like a way to describe the contours of a realism I can live with, but there's a question about whether the history of the theory whose contours of a realism I can describe supports open method.
Lori?
So this is kind of a follow-up on what Heather was asking about. I just want to, so what I'm hearing you say, which by the way, I think I can see how it's connected to quantum processes about say metaphysics, but I think it's different, but maybe I'm wrong. Which is, look, there are some questions in metaphysics, like maybe about grounding or essence or whatever, that's not going to be relevant to these issues about the interaction between science and metaphysics. But take questions like the nature of space-time or what fundamental objects are, or something like that. There, maybe the right approach is to embrace a kind of ambiguity. But what I'm wondering is what the implication is for the metaphysician. It doesn't seem to me that one has to say, well, the implication is there's nothing one should definitively say, but rather you should develop your metaphysics so that there's a kind of flexibility there. So, in a constrained way, if someone defends things about like points of a space, they shouldn't be worried about space-time in some particular interpretation, but like the configuration space or something like that. Or, that's just an example. I mean, obviously it would have to be broader than that, but yeah. So that's it's kind of like a kind of structuralism of metaphysics in a certain way.
Yes.
And that's why I think it's against quantum in a certain sense because all metaphysics is crap. And this is not. I mean, he does. I mean, at least that was the boss that I knew. Maybe he's changed. And I like this interpretation better because it shows that there's, it's a kind of sophisticated way about being natural stuff. Okay, good.
Yeah, I mean, something cool. There's a way this talk would have gone if I'd carried out my assignment, which is to say what metaphysicians should know about quantum field theory. Where something I would have said is, it seems curious to me that you might think metaphysicians should understand their job in such a way that the pictures they develop accommodate all possible physical theories, and not just the ones we happen to have latched onto and be obsessing about right now. And the kind of flexibility you're describing seems part and parcel of the project understood that way. Science quite being qua being, not being qua being the way the physics in our world, or we think is in our world, describes being.
And it's nice because it makes metaphysics more creative too. I mean, I'm not really a fan of the sort of let's just read off what the physicists have told us and that's what there is. I mean, that's
Yeah.
That's a little depressing if that's all we're
Yeah,
saying.
yeah, so the two types on one of my first slides, I think that's all, I mean, it's not what I do, but I think it's great people are doing it, and I think it could turn out that there's ways it informs either honestly or through the deranged understanding or practicing physicists with metaphysics, the progress of physics. That's good.
Joe.
I want to go back to QM infinity
Okay.
and ask you about this criteria of unitary equivalence.
Yeah.
So this is supposed to be a necessary condition for physical equivalence. But it seems a bit strong to me. So for two Hilbert space representations to be unitarily equivalent, my mapping from the operators in the right one to the operators in the left one has to preserve the products, right?
Yeah.
Yeah. That strikes me as way too strong. So that sounds like imposing the following condition on translations between two theories in natural language. I got my theory in Spanish, I got my theory in English over here, right? And in Spanish I have the words para and agua. One means stop, one means water, right? And you can stick them together and form the word umbrella. Then you look at the English word umbrella and you say, wait a minute, that doesn't come from sticking together two words in English. So that those two theories couldn't possibly be equivalent. That's why it just seems like this bizarre constraint. I don't know. It's so much stronger than preserving expectation values.
Yeah. I think you need much more than preserving expectation values, because any separable infinite dimensional Hilbert space
Right.
is equivalent as a Hilbert space.
Yeah, that's like the minimal sort of thing.
Yeah, but that's nothing. Like,
Right.
No matter how different your representation in mind is, we're going to preserve expectation values, provided you don't require algebraic isomorphism. I'm sure if I were clever, I'd be able to explain exactly why the concatenation of words in Spanish generate. Well, maybe that's it. Concatenating those words in Spanish generates a word.
Yes.
That doesn't happen in general. So words in Spanish are enclosed under the taking of products. Algebras are.
You could imagine languages where those operations were fully general, though. So why think that they have to be the same? Why think that they have to? And why think that they have to denote the same property in the world? If you think operators denote properties, why think that the operation of taking a product of two operators to get another operator? You okay? Yeah. Why think that those two things under the map are going to denote the same property? It seems
I'm not going to answer your
puzzling
question
to me.
head on. I'm going to try to say why I do think it's important to preserve products. So say these are the canonical commutation relations. It's the one thing I'm not going to give up. The one thing I don't think is ambiguous is the theory for whom these commutation relations are constitutive has a realization of these commutation relations in it. So here's some other. Not a complex number. Yeah, sorry. Never go on the right-hand side of canonical commutation relations. Here's another contender. I'm just going to insist this isn't the realization of the same theory as that unless it realizes the same commutation relations. And if we don't if products aren't preserved, there's going to be an ambiguity about whether the same commutation relations are realized that derives from an ambiguity about whether this is the same equation as So I think a part of what you need to make sense of to understand what it is to preserve the commutation relations, because the commutation relations involve products, is preservation of products. feel like I'm not saying this very clearly, but I feel like the product structure is part of the kind of constitutive structure of the theory. And so you want to ask whether this theory is realizing the same constitutive structure as that theory. There better be a way of understanding the product structure as being preserved.
David?
Just a quick thing on that. I mean, you just need, I agree with that, but it seems you can kind of respond more directly, and can you, in a sense, just say, well, okay, the presumptive case for unit equivalence goes something like, well, I got two different theories, but hang on, not really different, because the mathematical structures I have are isomorphic according to their own mathematical structures, structures isomorphism rules. There's no difference between these two Hilbert space representations, quiet Hilbert space representations. The only other differences are incidental. If somebody wants to come along and say, well, there is a weaker criterion of equivalence, which also deserves to be called equivalence, then they only have what it is. I mean, it seems to be that's the way the dialectic would go. In any AGFT, you could see somebody wanting to appeal to double kind of weak equivalence as a counter attempt to do that. The onus is to come up with that and then say, well, that does justify it, rather than to say that, try to make the general case that there can be no kind of weaker notion.
Yeah, I think that's so. Yeah, you got a better story?
But I'm not claiming the two theories are physically equivalent, right? So, right. No, this is on you to justify that.
I mean, the thought, I think the thoughts more generally, but suppose I've got two wildly different looking physical theories. One looks like a thermionic theory on n-dimensional spacetime, one looks like a bosonic field theory in k-dimensional spacetime. I might be able to say, well, look, because they are related in the following map, there is a sophisticated case to be made for why actually these are the same theories and a different description. But what won't do is for me to just say, well, because there might be some such map, we're not justified presumptively in saying there's a different theories.
Let's move on, I guess.
Yeah.
Jeanette?
It's a very quick question. I think it's maybe just reiterating what some of the other people have said. So I did a confession of my own opinion. So I interested in metaphysics. Start out with questions about what the world is like. And one of the characterizations you gave of scientific realism, I think, almost perfectly captures my attitude, which is there is no better guide than metaphysics.
It's
Yeah, right. And that's very weak. And I think it suggests already, even in that definition, that my beliefs, my particular beliefs with Euclid about what the world is like, ought to be as provisional as science is far. There's no guarantee that science is going to deliver a unequivocal answer. There's no guarantee that scientists themselves don't behave in ways that are sometimes, at odds as a group with this sort of. I'm wondering what I'm supposed to take away from your talk that's supposed to change my mind. Are you going to push me in another direction or make me worried about this attitude?
Yeah, I think if that's the way of your mind, you might blessing to. And I'm imagining a person who thinks there's a kind of clear picture of the world that emerges from paying attention to science.
The science is just going to tell us.
Science, yeah, that we can read metaphysics off. It's that kind of idea. Being guided is less demanding request of science than telling me what the case is, giving me clues. I think if that's your attitude towards how to think about the relation between science and metaphysics, we don't disagree. And I'm also happy for people to disagree and behave as I would. That's very important.
I have a question. So I'm a little confused about your gloss on what you take an interpretation to be, so I'm going to kind of keep pushing on that. I think I have a kind of an idea by enumeration of what you think interpretations are, but what you started out by saying was that you were going to go with something like the von Frosten notion that an interpretation is a description of the way the world could be such that theory is true. But then you went on to say that you think that for any theory you want to accept a different such interpretation for different phenomena. But you're thinking of these as being, and that's the whole local war strategy. But the local part of local war is like spatially local, right? It's sort of like conceptually local. When we're dealing with this problem, we use this interpretation. When we're dealing with that problem.
Right.
use that interpretation. So do you think that we're thinking when we attack these different problems that the world is different? Like when I'm thinking about Hawking radiation, I think the world is different than when I'm thinking about gravitational and quantum field theory combining. Is that, am I imagining two different worlds, or are you thinking that an interpretation is not an imagination of the way the world can be since the theory is something else?
Yeah.
Like a conceptual schema that helps you work through a problem.
I'm listening to my story about what interpretation is, but I don't think when you adopt different interpretations, you're thinking the world changes.
Yeah.
What you're thinking is how you situate the world with respect to the space of possible worlds, like what the space of possible worlds is changes.
Okay.
And the space of possible worlds is key to like the physical magnitudes you think are important or how they're organized. It's talking about the space of possible worlds allowed by the theory. It's talking about nomological possibilities
Right.
by the theory, ideas about that. So there's like a point there, but what you think going on with the point depends on how you situate it in a space of possibilities. So the point doesn't change, but what you think the point of physics is with respect to the point changes. So like I said, I think there's a way the world is, but I think there's lots of ways it could possibly be, and different collections of strategies for spelling out ways it could possibly be according to a given theory, or what I mean by different interpretations of a given theory. I need to praise theories for making room for that.
So a quick follow-up, because I might still be confused about what you're thinking. So my understanding of what you just said was that you think, here's what's going on. We've got one world that we're in, and when we employ different interpretations, we're thinking of different sets of nomologically possible worlds that we fit that world into.
Right.
Which means that if we've got two theories that make distinct predictions, it better be the case that in our actual world, the situations for which they make distinct predictions don't crop up. Is that right? So does that follow from what you said? Because we've got one world, right? The different theories say different things about what happens under these situations. So those situations have got to happen at merely possible worlds.
So you're talking about, so different interpretations can differ with respect to what?
So one interpretation says it's impossible for this situation to arise and for that to happen. The other interpretation says, no, that's possible. That situation A can arise and B can happen, right? So if those really are merely different interpretations, it better be the case that in our world, situation A doesn't arise, right?
Yeah, or that we keep really good track of how we're thinking about the theory in different circumstances.
Okay.
So I think some interpretations are stingy with respect to what the properties are. And they say, if I were to apply this interpretation in a different context, it would be similarly stingy. It wouldn't be possible if there's a number operator, say. And there's different interpretations you might apply in other contexts according to which there is a number operator. I don't think those are contradictions. I think you stick with your interpreted guns, but you recognize that you might want a different caliber in different circumstances.
All right, great.
Thank you.
Balliol College, Oxford. I'm not going to say too much about David. He is probably the leading defender of the ever-ending interpretation of quantum mechanics. I'm just going to let him take it from here.
Thank you. I intend to make no apologies for anything. I regret nothing. Makes an absolute mistake. This talk came out of a kind of building frustration with how some of the debate about so-called ontological or ontic structural realism has gone since James Lederman coined that phrase about 50 years ago. The kind of appallingly bowdlerized prehistory of the idea goes something like John Wall et al. Starts talking about the idea that we resolve various problems in philosophy of science and in scientific realism by supposing that scientific theories should only be trusted insofar as they tell us structural features about the world, that they make correct structural claims, but their claims about the nature of the world are unreliable and not to be trusted. Various people, Michael Redhead et al., suggested that that kind of structuralist turn in the interpretation of scientific theories was somehow also going to get us around otherwise embarrassing kinds of underdetermination in-extant theories, issues about identical particles, issues about whether fields are properties of space-time points or entities that occupy space-time points. James proposed that to really make sense of this whole package required you to take the structuralist thesis as being a thesis not just about the epistemology of science but about metaphysics. And exactly what the thesis is intended to be has been a kind of source of significant amounts of heat and perhaps rather less light. And a lot of the way this gets glossed in situations where you're trying to teach it to undergraduates for your sins is something like, you can end up doing things like, well, somehow relations are to be regarded as prior to objects, and then you start, somehow, and say, well, how do I understand this thing if it's a relation, if there aren't supposed to be things that are related by it? How can I have relations around later? So you can start wondering whether somehow there are objects, but the objects are composed of more structures and is carried on indefinitely. Or you can start saying somehow that the objects and properties of both objects and relations are both there, but somehow the relations are prior to the objects or more fundamental than the objects. And my kind of feeling, which you can confirm or deny, is that the only reason this kind of way of doing things isn't causing James to spin his grave is he's still with us. So the thought is that what seems to be being indicated by ostension in a lot of the kind of positive attempts to discuss an ontic structural realism is not well captured by these kind of ways of thinking, because the approach is not so much to reshift the priority of relation over object or something like that, but to somehow find a way of doing metaphysics that just doesn't look like that kind of way of structuring things at all. And the point of the talk is to really have a stab at not so much defending a thesis of that kind, but just stating one. As a kind of rather rough and ready first stab, attempt to see if it explicates something along the lines of what various people advocating some kind of ontic structuralism have in mind. Unsurprisingly, I have an ulterior motive. I do think the position is at least moderately defensible, or something along the lines of it looks like it's the kind of thing that one might maybe have in mind. He says kind of weakening the thesis to the point of total attenuation. But I'm mostly just going to try to state a position and show a contrast, rather than really try to make a sustained case for that position. And I'm going to come at it in a rather indirect way, which kind of links to the other reason that led me to give this talk, which was another frustration in trying to persuade undergraduates of what, if anything, was interesting in the debate between syntactic and semantic views of scientific theories. Just for a background point, that syntactic versus semantic debate, who's come across that? So, quite a lot, but by no means everyone. Okay, fine. So I will try to go quickly enough that those who haven't heard of it are lost, but slowly enough that those who have heard of it are bored to tears. That way, by the end of it, I can more or less get away with anything because no one's listening. Okay, so semantic versus syntactic views of theory is an idea that comes out of a debate about what the right formulation of a scientific theory is. And there's a kind of, sometimes gets called the syntactic views, I think Van Fraassen calls the received view of theories, which you can kind of see as a descendant of ideas in logical empiricism. A kind of first stab at it goes probably something like this. From a syntactic view, a theory is something like a set of sentences in some formal logical language such that a variety of unspecified properties apply. Something like, things like recursive accessorization, I can do closed under implication, can all be derived from a finite set of axioms or a finitely enumerable set of axioms or recursively enumerable set of axioms or something like that. And the semantic view again, as a kind of first gloss, says something like, a theory is a collection of set theoretically related entities plus the dot law. Put that way, it starts to look extremely obscure. Where the is coming from. A kind of caricature of the trajectory here goes something like the logical empiricists came up with this kind of syntactic received way of thinking about a theory. People like Patrick Suplis came along and said something like, well, that doesn't seem to be a very good match to what science really does. We should be using mathematics, not meta-mathematics, and started to characterize the theory using issues of, instead of using first order logic, using various pieces of set theory. Put that way, it looks kind of unconvincing on the long angle. But I'm here to tell you that working scientists don't use a hell of a lot of axiomatized set theory as a rule as well. But I think there is an interesting distinction here. Here's a better way of cashing it out. Representing the syntactic view as a set of formal language sentences is really just a way of trying to get formal and precise and be able to say things about the somewhat more intuitive and rough idea that what a theory is just a set of sentences. It's a collection of claims in language. So I'll try that as a variation. So I think something like Newton's laws gives a pretty good paradigm of why, when one first comes to this, can seem an awfully sensible way of thinking. What's Newtonian gravity as Newton wrote it down? Well, it certainly looks an awful lot as if it's something like, here's a collection of laws. They're sentences. Well, they won't be in English, they're probably in Latin. But there are sentences. These are the claims the theory is making. The claims are enumerated in natural language and given in a list. And the semantic view is a kind of way of formalizing and getting at the idea that what a theory is instead is some collection of mathematical objects. So, again, if you think about Newtonian physics, on that kind of construal of Newtonian physics, then the theory is something like a collection of Euclidean affine spaces and trajectories and lines in those spaces such that the lines satisfy such and such differential equations. Or something along those kind of lines. Or to give a more modern example, a quantum theory is a collection of is specified by a Hilbert space together with some preferred operators on that Hilbert space, and maybe the models are intended to be trajectories through that Hilbert space satisfying Schrödinger's equation, or something along those lines. Okay, so as a stab at what the distinction is that's actually interesting, I'll try that way of putting it. And from that perspective, the attempt to go from that kind of natural language understanding of it to the understanding of a theory as a collection of logical statements, or the move from a rather general loose mathematical characterization to a sharp characterization of set theory, is something we can think of rather akin to the formalization of ordinary reasoning. It's not intended that actual reasoning really happens in first order logic, but the idealization it does is a great way to try to prove things about the process of reasoning and say interesting meta things about it. So the thought is that really, along the move in how we characterize the scientific theory, has this kind of shape to it. Alright, but you could still say, so what? I mean, I can characterize a theory in a bunch of ways. Maybe I can characterize it as a set of sentences. Maybe I can characterize it as a set of models. Maybe that's an interesting question in the sociology of science. Just maybe it's an interesting question in the more boring bits of philosophy of science. Why is it relevant to sexy conferences about metaphysics? And to kind of strengthen that worry before I try to say something back against it, notice that there's a kind of way in which it seems we can go relatively readily between these ways of talking. So if I've got a theory characterized in language, what I normally do with that theory is I use it to build some mathematical models, and then I do stuff with those mathematical models. Conversely, if my theory is a set of mathematical models, and I want to tell you and I want you to know which one it is, then somehow I better communicate to you which mathematical model I have in mind, and absent some kind of telepathic ability, the way I'm going to communicate that to you is I'm probably going to write it down. There's some sense in which, even if there's some abstract sense of a scientific theory whereby any old collection of mathematical models satisfying such and such abstract properties counts as a theory, those theories which we can have conversations about are by definition theories we can describe as language, at least to some degree. And if you really want to push that and get a little bit of leverage out of those formal notions, notice that at least if we characterize our theory in first order form, and at least if we characterize our models as pieces of set theory, then Gödel's completeness theorem tells us that we've got a fairly natural duality between syntactic and semantic descriptions of the same goings on. Okay, so